Hey guys, Mr. Gardner here. Today I want to talk about actually simplifying linear expressions. So yesterday we really just reviewed the properties of math: associative, commutative, inverse, and distributive. Today we want to actually talk about using those things to simplify linear expressions. So our objective is that we want to simplify linear expressions with 80% accuracy. We're always looking for that 4 out of 5 or 5 out of 5 on the weekly formative. One thing we got to remember is what a linear expression is. So a linear expression is just an expression where all the variables are raised to the first power. So there's no squares or cube roots or anything like that. And also a linear expression that when graphed, it forms a line. Okay, and the other thing we want to review really quick before we get through today is just our adding and subtracting rules. If your numbers have the same sign, you're just going to add them up and keep that sign. If they have different signs, subtract the smaller number from the bigger number and keep the sign of the bigger number. And for subtraction, we're just going to change subtraction to adding the opposite. So to remember those rules. And then for multiply and divide, if we're multiplying two terms and they both have the same sign, then we're always going to get a positive. And if they have opposite signs, we're going to get a negative. So those are just some reviewed concepts that we want to go over really quick. For actually simplifying these terms, we got to just think about a few things first. First thing we want to think about is combining terms. So when we talk about combining terms, we're talking about combining like terms. And if we remember back to 6th grade, like terms are terms that have the same variable and exponent. So like x, 2x, 5x, these are all like terms. Right? They might have a different coefficient in front, but the variable and the exponent's the same. Whereas x, y, x squared, these are not like terms. Okay, because these are different variables. This variable has a squared exponent, so that's not going to be the same as this, even though the variable's the same. So these are not like terms. So the first thing we got to remember is what like terms are versus not like terms. Okay, so that's really important. And when we're doing like terms, when we're talking about combining, we're just talking about adding and subtracting. There's a whole different set of rules when we start talking about multiplying that we'll get into later. But when we're adding and subtracting, you have to be like terms or they cannot be added or subtracted. Okay? So a really easy example of this is something like x plus x. All right? And if you remember back to our identity property, this is really 1x plus 1x. Okay? Because 1 times anything is just itself. And if I have 1x and I'm adding to it another x, then I have 2 x's. If that concept's tough to think about if you had 1 apple and 1 apple. You put them together, you'd have 2 apples, right? So x is just like that word apple, okay? Now, if you want to see like unlike terms, if I had something like x plus y, then that really just equals x plus y. I can't combine those terms. They're not the same. So I can't simplify or change that at all. Unlike this one where they are like terms and I could change x plus x to 2 x's, okay? So that's just a really simple example of what we'll be talking about. So the next thing we can look at, we'll just put a box around this one, is let's just talk about maybe when they start getting switched around a little bit. So we could be looking at expressions like this: 2x plus 7 plus 3x minus 5. Now in something like this, right, as it stands, I can't combine these two, and I can't combine these, and I can't combine these. But if we remember back to commutative property, it says that as long as I don't change my order of operations, which this wouldn't because it's all addition, that I can move around these terms to put them where they would go so that I can combine them. So if I'm looking at this, I have x's and x's, and I've got constants and constants. So then I just want to move these around. So if I do that and I rewrite it, I get 2x plus 3x. Remember, the sign always goes with the term, plus 7 minus 5. Now the next thing I could do is I can change this to adding the opposite, because that's what we've said to do. So this would really become 2x plus 3x plus 7 plus negative 5, because it was minus 5, so we're adding the opposite, which is plus negative 5. Okay? And now this is really nice, because I can look at these two terms and go, well, those are like, and these are like, so I can combine those. So if I have 2x's and I add 3x's, then I have 5x's. Okay? Same thing with apples. If I had 2 apples and 3 apples, I have 5 apples. All right? And now if I have 7 plus negative 5, I look at my rules, different signs, subtract the smaller, so then I have 7 minus 5, and that gives me 2, and I keep the sign of the bigger number. Well, 7 was the bigger number, and 7 was positive, so I know I have positive 2. So that's really nice, because now I've made an equivalent expression to this one. So what we can say is that this expression here is equivalent to the top, and this expression here is equivalent to this one, and this last one is equivalent to all three. Okay, but this is just the most simple form of this expression up here. I can't go any further because these aren't like terms. I'm not going to be able to add those together. Let's take a look at what happens when we have problems that are addition still, but we have some associative property to deal with. So that case I'm talking about is if you have something like this. So if I have something like this, I can still deal with it, right? Because again, associative property means I can just group things the way I want to, which means I can ungroup things. So right now they're grouped, but because it's all addition, I can get rid of a lot of the grouping. I could literally make this 2x plus 3 plus 5 plus negative 5x. And the reason why I can do that is because nothing can be done in here. I can't combine those terms, and I can't combine these terms either. So really, I'm not really doing anything here when I take the parentheses away, other than saying I have evaluated or simplified those parentheses, and nothing can be done. Okay? So I'm not really ungrouping. I'm really just simplifying. Now, though, we can see that, like our last problem, we can move some stuff around so that we can start to combine these terms. Now, I like this here because these are both constants, so I can work with those. But this term here needs to move. And I could move the first one too, but I'm going to move this one. And I'm going to move it to the front. Okay? And so what I would get is negative 5x. This is positive, so it's plus 2x plus 3 plus 5. And again, I've just used commutative property because I'm just moving terms around, commuting them. Okay, and now I can use associative property again because I can say I'm going to work with those, and then I'm going to work with these as groups. Okay, so this is now associative again. And order of operations tells me to do parentheses, so I would do these. Again, I'm going to use this different signs. So I'm going to subtract 5 minus 2, gives me 3. The 5 is negative and it's bigger, so negative 3x plus, and I'm going to do this, 3 plus 5 is 8. And I get negative 3x plus 8. So it tells me along each one of these steps I have an equivalency, and this is just my most simplified form. And again, I can't do anything with this because this is the most simplified I can get to. So I leave that there, and that's my answer, right? So this would be the simplify step. Okay? Next, you might be asking, well, what if there's multiplication in the problems? What do I do then? And we can look at this case here where I have a 3 and it's times the quantity 2x plus 2. Well, now we just use distributive property, right? Which distributive property tells us I'm going to use the number outside the parentheses and multiply it by both of the addends inside the parentheses. So that means I'm going to multiply here and here. Okay, and I'm just going to rewrite this to keep myself organized. is now this is going to become 3 times 2x plus 3 times 2. So there I just distributed. All right, now I've distributed, and in this step now, I want to maybe make associative. I don't have to, but it might just help me clean it up. To see that now I have 3 times 2x plus 3 times 2. Okay, and now I just do multiplication, right? They don't have to be like terms when you multiply. Okay, that is only for addition and subtraction. So here I just use this. 3 times 2 is 6, and I haven't done anything to the x, so it's 6x. I'm still adding. Okay, and that's over to here, and this is 3 times 2, which is 6. And so that's really nice. I got 6x plus 6. All right, and then that's simplified. Okay? But you might also get the case where it's asking you a question like 6x plus 6, simplify that. Okay, and in this case, we have to think about factoring. So this is kind of where division comes into play. So when we're factoring these two, we want to think about what number goes into both of them. Well, the nice thing is they're both 6. So I could think about dividing both of these by 6. Right? And then, so that means I'm going to take 6 outside here since I'm factoring out of both. And 6 divided by 6 is 1. And 6 divided by 6 is 1 again. So plus 1. So really, if I really want to simplify, this is more simplified. Right? Because now I've been able to take the 6 out of both, and I'm left with 6 times 1x plus 1. The quantity, because now I've factored. So this step here is factoring. And when we factor, we always bring out the number we factored, and then inside the parentheses we leave the solutions to the division we just did. Okay, so that's really nice when we're doing problems like that. Let's look at another one of these that's in this kind of reverse order right here. So let's say we were left with something like, let me get these out of here. Let's say we were left with something like 6x plus 3. Again, this seems like it's in simplest form because I can't combine these terms. But if we take a deeper look at this, then I have a 6 and a 3, and I can go, oh, wait a minute, I know that these share a factor. Well, what factor? Well, 3. I know that these both share a 3, so I can divide out 3. And again, if we're going to divide out 3, it's going to come to the outside. And in the inside, we're going to put in the division we've done. So 6 divided by 3 is 2x, because we still have that x. Okay, and then we're plus 3 divided by 3 is 1. So in this case, we've factored out the 3, and we're left with 2x plus 1. So now kind of what we're left with is distributive property. But in reverse. All right, and all that really is it's just factoring. All we've done is factor out a common term, okay? And really what you want to be able to factor out is factor out the greatest common factor, the GCF. Okay, and really what happens is it becomes GCF, and then in here you get term 1, and here is term 2. Right? And that's really the GCF of those two terms. If 6 and 3, their GCF is 3. So we can do that, and we can find it in reverse. Let's look at an example of distributive property, and let's use fast food to help our example out here. Sometimes when we use just numbers, it can be a little bit confusing. So let's do something we all kind of know about, and maybe it'll help it make more sense. So let's think of a term in parentheses. So we saw from earlier, we had something in parentheses like 2x plus 1. Let's say that that's our parentheses. Well, let's think of 2x plus 1 as like a value meal, let's say at Taco Bell. Okay? And so this is this. And in this value meal, you get 1. Oh, look at that yummy taco. You get 2 delicious tacos, and you get a beverage. Okay? Soda. So that's a combo meal, right, at Taco Bell. Well, let's say we wanted to order 3 of those. I want 3 combos. Okay, well this 3 is kind of like the number that would be outside. Let's say this number's here. Okay, and so if you think about that, then I want 3 combo meals. Then how many tacos am I going to get? Well, I'm going to get 1 meal's worth. I'm going to get 2 meals worth. I understand that my tacos look fantastic, guys. You don't need to tell me, but I get it. And you get 3 meals worth of tacos. I don't know why they're starting to kind of look like hot dogs. This is all the fixings. Oh, look at all that good stuff. Yum. Chomp. Okay, and you would get 3 drinks also. 1, 2, 3. And just make sure we know what that is. Those are the sodas. So if you think about this, right, it's like distributive property. I want 3 of these Taco Bell meals. And the Taco Bell meal is the parentheses. And so there's 1 meal, 2 meals, 3 meals, but total I get 6x or 6 tacos. And in a regular meal I get 1 drink, but in this I got 1, 2, 3 drinks. So plus 3. So from the example you can kind of see, right, is that we have to distribute this 3 to both things that are in the combo meal. So you can think of the parentheses kind of like the bag that has the food in it. And if I'm going to order multiples of that bag, I want everything I'm supposed to get, right? I want the 6 tacos and 3 drinks. I don't want to just get 6 tacos and 1 drink and we're all sharing.